Hey everybody, welcome back. I'm sorry it took so long, but I did have a couple of things I needed to take care of around the house and, work and all that. I really haven't been able to find a lot of time to do any recording. And when I did this episode last, I was using my avatar, so since I've got this set up, I didn't like the way that the episode was sounding, so I decided to go ahead and redo it from scratch. And that's why it's taken so long to get this up. Today, on the Thread of God, we're covering reducing irreducible complexity. But before we get to that, I need to cover a couple of tweets that pulled up chronologically in here. First is this claim that the Bible is a guide for how life started, purpose, morals, whatnot. I debated on covering this now, but decided to stick a pin in it and come back to it later. I'm wanting to deal with the science and history aspects first, and then biblical claims, and then moving straight on to the critique of the actual sources that he's pulling from. I also need to cover this life from non-life thing. Now I'm going to be covering that in more detail in an abiogenesis video on down the line, but for now we're going to be covering this reference, which is itself a video and is the subject of what we're talking about today. It's called The Amazing Flagellum. It was produced in 2016 by the Discovery Institute. So it's already a little dubious to me. But hey, let's take a look.
In Darwin's Black Box in 1996, Behe spotlighted and made famous a number of really interesting discoveries that had been occurring in biochemistry and cell biology over the last 2 or 3 decades.
So Darwin's Black Box is a book that was published by Michael Behe in 1996 with a second edition released in 2006. Now keep those dates in mind because they're going to be important later. But suffice to say for now, it came under considerable criticism from the scientific community, and I will be getting into that in just a little bit, but let's continue for now.
And what biologists, molecular biologists, cell biologists, microbiologists have been discovering is that at the level of individual cells, there are little tiny examples of nanotechnology, little tiny machines.
Well, when you say it like that, it seems impressive. It really does. But the complex structures that he's talking about are not indicative of design, not when they're alive. When you have a biological organism that responds to selective pressures, it's no longer a design issue, it's a natural selection issue. Design would be something like a watch or an arrowhead, something that cannot reproduce on its own. But things that can reproduce on their own, that is not a design factor. Let's move on.
The Flagellar Motor is the one that Behe made most famous. It's a rotary engine that powers a whip-like tail, a protein tail that functions like a propeller, and it moves the bacterium through liquid, enabling the bacterium to essentially track down its food supply. And this little machine includes a rotor, a stator, a drive shaft, a U-joint, bushings, bearings, and a whip-like tail that functions like a propeller. And the machine in some bacterial systems turns at 100,000 RPMs in one direction and can reverse direction on a quarter of a turn and turn 100,000 RPM in the other direction.
All right, so what we have here is a massive oversimplification of what is actually going on. Now, the parts described, like bearings, U-joints, whatever, they are really, really overly simplified. These are drawings. This isn't what this actually looks like under a microscope. What you'd see if you looked at it under a microscope would be little protein chains that are reacting to thermal noise. They look nothing like this at all. But this is used as a way to make it simpler to understand, and as a result of this simplicity, it is extremely pervasive, and we'll get into that a little bit more. Now, what I have found on this says that all of this is ignoring the fact that a simpler flagellum or earlier secretor system existed, and they have been documented in microfossils in the fossil record. So we have a really good understanding already of where the flagellum came from and where these structures came from in the first place. And it's not a design, it is a traceable evolutionary biology. Now, I did find this in about a minute on Google Scholar, and this article says that proven methods like natural selection can explain this, and they are ignored in favor of a supernatural explanation. Now, supernatural explanations, by their nature, are untestable and unfalsifiable. Now, that's a problem because science does not deal in supernatural. It deals in things that are testable and are potentially falsifiable. And if you can't meet those two criteria, it's not worth considering at all.
This signal transduction system is actually a short-term memory system where the cell is, if it's going in the direction of an attractant, a nutrient that it can use to metabolize, it follows that chemical gradient. If it's a repellent, it will sense that and move in the opposite direction.
Yes, of course, natural selection makes organisms favor food over something that could kill them. It's the way that it works. If you don't run from danger and towards food, natural selection is going to have a field day with you because you're going to die in short order and your genes are going to be removed from the gene pool, and there you go. That's natural selection at work.
It's an extraordinary piece of nanotechnology. It's high tech in low life. And so just by spotlighting these extraordinary pieces of nanotechnology inside cells, and the flagellar motor wasn't the only one by any means, Behe, in a sense, opened up a window for people. He opened up the black box of the inner workings of the cell and said, look, this is much more complex than anything than anything that the early evolutionary biologists had envisioned. Darwin knew nothing of this type of nanotechnology in cells, and at the very least, we've got to come up with an explanation for this.
Yes, I agree with you. Absolutely. We do need an explanation for all of this, and we have one. It's called natural selection. Now, there are more advanced concepts of evolution that I'm going to be getting into later that focus on what will be the more genetic aspect of it, but for now we need to focus on natural selection itself and what natural selection demands. Natural selection is environmental pressures, food, predators, climate, those kinds of things are environmental pressures, among other things that can be applied to this, that are directly applied to the organism. Take the Galapagos finches, for example. This was one of the first tip-offs for Darwin that there was something going on. Now, there are 14 species of finch on the Galapagos Islands, and they're all specialized for various food sources and various lifestyles. Now, this wasn't always the case. The first group that blew into the Galapagos Islands, they were in a really fortunate spot. When they landed on the Galapagos Islands, they had no predators and plenty of food. So they expanded out considerably and covered the entire island chain in short order. Now, this became a problem because eventually they were competing for the same food sources. But that's where natural selection comes in. Natural selection selected for certain finches with a better ability to, say, crack nuts or feed off of cactuses or eat ticks off of tortoises or whatever else they could find, digging, whatever. Now, eventually, they started mating only with those organisms. They started mating only with those fellows in that niche, which meant that they were now genetically isolated. And I know I said I was going to cover genetic aspects a little bit later, but this is the one aspect that is directly relevant. Now, when you isolate a group genetically, they can diversify a lot faster because the parent gene pool is not suppressing the aberrations that pop up. And this includes beneficial mutations as well. The aberration is usually overridden by the parent genome. So because that restriction was released, or relaxed in this case, I should say, they were able to have those mutations build up, and the beneficial ones that situated them for various food sources those are the ones that proliferated throughout that individual population. They're still finches. So that whole, they're still birds or still finches, yes, of course they're still finches, but there are different species of finch, and there are different species because they don't even try to mate with another species of finch. And even if they tried, they may not produce viable offspring. So that's where that speciation event happens. 14 different species of finch are on the Galapagos Islands because of natural selection. This whole idea that evolution demands that a bird produce something that's not a bird is completely insane and is not at all what evolution teaches, but we'll be getting into more detail on that down the line. Now, the important thing to keep in mind for this specific subject of irreducible complexity is what a vestige is. A vestige is a structure that is no longer serving its original intended purpose. It's not completely worthless necessarily, but it's not serving its original purpose. Take the pelvis of a whale, for example. A pelvis is a load-bearing structure that supports tetrapods, or tetrapods and their descendants. All land animals have one. It supports our weight so that we can walk. Now, whales do have a pelvis. It's obviously not effective for load-bearing and supporting their weight while walking on land anymore, but it's not completely useless. It has been repurposed specifically for the one task of reproduction. It's not serving its original intended purpose, therefore it is a vestige. Vestiges do exist, both physically and genetically. Now, something like the flagellar motor, what is forgotten is that there is a possibility, and it's well documented actually, so it's not really a possibility, it's well documented that a simpler system pre-existed. A shorter flagellum, a secretor in place of that. This gene was doubled, so it was able to go on its own little program, while this one served its original function until this served a better function. Then the original gene kind of got cut off or repurposed, and that's the way evolution works. It works for the benefit of the organism, but it's effectively random, because evolution is not going to make something that's better food for its prey, for its predators. That's what artificial selection does, and that's what we do when we use the same processes of mutation to kind of make these animals look and act the way that we want. That's how we domesticated wolves to dogs and all that mess. Evolution is an incredibly simple concept to get, but it takes a degree of understanding to really grasp it, and I'll get into why this particular argument is more pervasive here in just a moment. Now, remember when I said that Behe's book was brought under heavy scrutiny in the scientific community? He was accused of the argument from design, which is in effect presuppositionalism, where you presuppose the answer to what you're proposing without any evidence to back it up. That's a problem, and it's also logically fallacious. Now, he was also accused of submitting, like I said, unfalsifiable claims, which are completely useless to science, and ignoring simpler life forms in the fossil record. Now, all of this culminated not only in the scientific community, where it was shown to be completely wrong, but it also came to a head in the Kitzmiller versus Dover case, where not only was science showing irreducible complexity to be wrong and completely fallacious, but it was found to be completely wrong in a court of law. Now, the Kitzmiller versus Dover case happened in 2005. It was a case brought up concerning teaching intelligent design in school. Now, this was overseen by a Christian judge, Judge John E. Jones, and he wound up ruling against intelligent design, saying that it was not science and that it had no business in school curriculum. Now, the interesting part is that Behe's testimony was a big part of why the judge ruled against intelligent design. He had a lot to say about Behe's testimony, including that he used an incorrect definition of theory to the point where astrology could be considered a scientific field of study under his definition. He was also shown peer-reviewed articles, textbooks, and other evidence presented, but Behe said it wasn't good enough. So, on top of all of this that's going on, the judge ruling and saying these things about what Behe presented, why is intelligent design, specifically this particular irreducible complexity argument, still being tossed around? Very simple. It's so pervasive because it's simple. It's an easy concept for someone to wrap their head around, especially when they already have a religious foundation that says that their whole world, everything they know was created by a powerful being that is well beyond them. So because it is such a simplistic answer, humans really, honestly, most of us, we like the simple answers. Digging for the right answers generally doesn't come very easy to humans. We have to train ourselves to do that. We have to train ourselves to think like that, to go, that sounds good, but is it right? And what do you have to back it up? Now, scientists and scientifically minded people are really good at that. But those that are emotionally invested in their beliefs, they have a hard time doing that, because on some level I think they know that it's wrong, but they don't want to know that it's wrong. So they just live the comfortable lie in place of the hard truth. Now, evolution does clearly explain irreducibly complex systems. It's simple. Like I was describing earlier, gene duplications that allow this one gene to go off on its own program and this one to continue serving its original purpose. That's how it works. These mutations are not always detrimental. They are often neutral, but every so often you wind up with a good one. And that is what drives this. What is best for the survival of the organism over the long term. And not just one organism, but the entire population. Now, like I said in my green screen test video, I'm going to be covering peer-reviewed articles from this tweet next episode. But before that, I want to cover this video here. This guy found me when I was over on Hoven's channel criticizing his cowardice to not want to finish an episode, finish his debate with Aaron by skipping to the end, but that's neither here nor there. So there's going to be a gap before I get to the next episode, because I'm going to be covering this first. It's going to be relatively quick, I hope. But after that, I'll be getting back to the threat of God. Now, if you want to find me, drop me suggestions. You can always find me here on YouTube or in either of these two other places on Twitter and Facebook. If you have any suggestions, go ahead. Drop them on any of these three platforms. And as always, stay curious and hope you enjoyed.